video is going to be on relating f prime of x, and f double prime of x, and it's going to be based off of the graph of f of x that is provided. So there are a lot of typos on this page, and I apologize for that, but I will make sure that they are fixed in this video, and we already fixed them in class as well, okay? So 16, use the graph displayed above to evaluate the following. If the exact value cannot be determined, answer with positive or negative. Okay, so for this first one, typo, this should be f of negative 2, okay? And for this one, we're just, what is the output at negative 2? Within this graph, it is going to be 0. Part B, f prime of 9. So f prime, that's going to be the first derivative, so we want to know the slope at x equals 9, given that this is a graph of f of x. If we look at x equals 9, the slope of the tangent line at x equals 9 is going to be negative, so we just put f prime of 9 is negative. Or you can say less than 0, either one works. All right, C is f double prime of 19, so this is going to be talking about concavity at that point. So I'm going to go to x equals 19. If I look at this, I can see that it is concave up on the left side of 19, and then concave down. So this is in fact a turning point for concavity for f of x. So f double prime of 19 is going to be equal to 0, because that is where the second derivative will be changing signs because of that concavity. All right, part D is the limit as x approaches 4 for f of x. So if we look at 4, we can see that the function is approaching the same y value from both sides. So that means the limit is equal to 7. And if we look at G, this is asking, okay, well, what's the output when x is equal to 4? The answer is also 7. And these two combined, that is actually the conditions for continuity. And we will talk about that more as we go through the next unit, okay? Part E, this is actually the limit process, aka the definition of the derivative. That should be as delta x approaches 0, because if you recall, we are closing the gap between point A and point B based on that diagram we talked about before. So this is actually equivalent to f prime of 19. And if we look at f prime of, or if we look at f of 19, we want to look at the slope of the tangent line at that point, and it's going to be greater than 0. So it will be positive. F is going to be the limit as x approaches infinity for f of x. If we look at this, it is decreasing in value, so that means it is negative infinity or does not exist. Both are acceptable. All right, part H is f prime of negative 2. Again, because it's the first derivative, we are looking at the slope of the tangent line at x equals negative 2, and it is going to be positive or greater than 0. I, f double prime of 16, we are looking at the concavity at x equals 16. So all of this here from x equals 9 to 19 is going to be concave up. So any point within this interval, their second derivative is going to be greater than 0 or positive, because they are all points that lie where f of x is concave up. So that means this will be greater than 0. J is the limit process again. That should be as delta x approaches 0. And this is equivalent to f prime of 16. So if we zoom in on x equals 16, we can see that it is located for, oh, it's a minimum, okay? So that means the slope of the tangent line at this minimum is going to be 0. Therefore, f prime of 16 is equal to 0, because that is a local extrema. K is going to be the limit as x approaches 22 for f of x. If we zoom in on 22, I can see that from the left and the right, we are approaching the y value of negative 4. So that means the limit as x approaches 22 for f of x is negative 4. L, f of 19, it's just asking for the output. And at 19, the output is going to be -7. Okay, next, M, we have f double prime of 11. So if we look at 11, we talked about this interval before. From 9 to 19, all of these points are located on where f of x is concave up, and this includes 11. So that means the second derivative at 11 is going to be greater than 0, or positive. N, okay, that should say as h approaches 0, and then the delta x, oh, I can do this actually. The delta x should be h, and then the delta x in the bottom will also be h. Forgot I can just basically erase it out and rewrite it so it's a little bit neater. So as x approaches h, and then h in the denominator. Sorry, that's still incorrect. That should be as h approaches 0. All right. So this, again, is just the first derivative. So I want f prime of 11. And then if I look at the graph at 11, the slope of the tangent line is going to be negative. So this is less than 0. F prime of 19, I feel like we already did this one. Maybe not. So f prime of 9, oh yeah, we did. It was here. It was in the limit process. So f prime of 19, E is going to be the same answer for O, which is greater than 0. P, the limit as x approaches -infinity for f of x. So now we're going in the other direction, but the y values are still going to -infinity or does not exist. Q is different. This is the average rate of change. So we want the output at 19, which is -7, minus the output at 9, which is -5, divided by 19 minus 9. So if we double check, f of 19 is -7 here. F of 9 is -5. So again, this is just average rate of change. So we'll have -5 plus 5, which is -2, divided by 10, which is equal to -1/5. And if we were to look at that secant line, if we connect it from 9 to 19, it is slightly negative, so that's where we get the -1/5 slope for that secant line. All right, we have another average rate of change. So at 22, the value is -4, and then at 11, the value is -12. So we have -4 minus -12 divided by 22 minus 11. -4 plus 12 is going to give us 8 divided by 11. And if we were to draw that secant line from 11 to 22, we'll make this one the tan. We can see that that one is positive. Okay. All right, so 17 says, sketch a pattern for f prime of x and for f double prime. So for f prime, we want to look at increasing versus decreasing, since this is a graph of f of x. So if I look at this, I can see that from -infinity to 4, my graph is increasing. Therefore, the slope is positive. So I'm going to go ahead and put a plus to +4. As we continue on, we change. This is a maximum, so we are going to change from increasing to decreasing, and it's going to decrease all the way to 16. Okay, so from 4 to 16, our function is decreasing, therefore the slope is negative. The next stop, we will be increasing from 16 to 22, and then we will finish off by decreasing from 22 to infinity. So I forgot. So we'll add, and then 22, and then it's decreasing. Okay. So the local extrema, or it could be global, depending on which way it's facing. I guess this one, we do have a global. Yeah, we have a global maximum at 4, 7. So any extrema, really. that's going to be the numbers that you see on your sign pattern for f prime of x. Now for f double prime, we want to see where the concavity is changing, and that's going to be at 9, -5, and 19, -7. So I'm going to include 9 and 19 on my sign pattern. Now if I look at this, I can see that we are concave down first, and then concave up. Whoops, let's try the blue. And then we are concave down again. So we go down, up, down. Therefore, the second derivative will be minus, plus, minus. And these will be your points of inflection at 9 and 13 because f double prime is changing signs. All right, hope this helps.